now that we have established what sample space is and how to find our sample spaces, we're going to move into probability. So exactly how do we find probability? What is probability? All that good stuff. So we're going to put up here a definition for probability. With probability, what we're looking for is what are the chances of winning the lottery? One person is going to win out of how many people? That one person, that one win is the desired event. That's what we're looking at. So what we're going to find here is probability is your desired outcome, and we're going to divide that by the total outcomes. And that itself is probability. You can write this so your answer can be written as a fraction or a decimal or a percent. So you can hear probability being said like, you got a 1 out of 2 chance, 1 over 2. 1 over 2 is the same as having a 50% chance. So you got percent, fractions, decimals. They all represent that probability. So if we look here on our first example, it says, what's the probability of rolling a 6 on a normal-sided die? Okay, I think I might even have one right here in my drawer. Cool. So what's the probability of taking this guy, rolling it, and getting a 6? Well, the desired outcome is to get the 6, but on the dice, we have the option 1, 2, 3, 4, 5, 6. So we have 6 total outcomes, but only 1 desired. So that would be 1 over 6. And if we wanted to represent that as a decimal, 1 divided by 6, that is about 0.167, which would then be written as about 16.67%. Okay, you don't have to represent it in all 3 ways. I'm just showing that now for example. All right, our second example. What's the probability of flipping a coin twice and landing on heads exactly 1 time? So just like we've done before, we might need to figure out what is our sample space. How many options do we have? So we know we could get heads, heads, heads and tails, tails and heads, tails and tails. So we have 4 total outcomes, and we want to know where we're going to get heads only once. So that's these 2 here. So that's 2 out of 4. That's your probability. We're going to reduce that to 1/2, which we could say is 0.5, or again, 50%. Probability. It's not too bad. Desired outcome over total outcome. So we've got one more here. What's the probability of rolling doubles with 2 dice? So what we need to know is how many desired outcomes do we have and how many total outcomes do we have. If we're going to roll a dice twice, if you remember the fundamental counting principle, we're going to have 2 events. The first event, I roll the die. How many outcomes do we have? Well, we saw in number 1, we're going to have 6 outcomes. Same die, 6 outcomes. So if we multiply that, we're going to have 36 total outcomes. And then from here, I want to know how many chances we'll have of rolling doubles. Well, that means we're going to get 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So that right there, that is 6 options of getting doubles out of 36 total options. So that's 6 out of 36, which is a 1 out of 6 chance. Probability. Desired outcome over total outcomes. Give it a go.